right, on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we're going to be going over today. Today we're just going to do some light reading. We're back inside of our Web3Py favorites module, and we're still inside of the deploy a contract to the EVM section of that module. Like I said, today we're going to do some light reading, and then we're going to pick up where we left off from yesterday. So note, we will be using a private key that is provided by Anvil, which is a local Ethereum development environment that allows us to test and deploy small contracts without needing to connect to a live Ethereum network. Anvil provides a set of pre-funded accounts that we can use to test our contracts, and we can use the private key of one of these accounts to sign our transaction. Now, this is the private key variable that we will use to sign the transaction. You can see here we have private key, which is acting as our variable, and we're going to set that equal to OX your private key here. Obviously, the private key would go there. No, we will need to replace the OX your private key here with the actual private key that we want to use to sign the transaction, like I just said. Now we have the private key, we can use it to sign the transaction. Note, we must pass in private key as an argument to the signed transaction method. This is how we will implement that into our code. So you can see we have signed transaction variable equals w3.eth.account.signed transaction. And as a parameter, you can see we pass in transaction and private key equals private key. This will sign the transaction using the private key that we provided, and it will return a signed transaction object that we can send to the EMV, or that can be sent to the EMV, same thing. Now that we have signed the transaction, we can send it to the EMV. We will also be printing the signed transaction to see the compilation details. At this point, we can compile the code and see if it runs without any errors. If the code compiles successfully, we can proceed to send the signed transaction to the EMV. Now, this is stuff that we've already done. I already showed you that we actually are able to deploy this transaction and sign it because everything is set up behind the scenes. We're just walking through the motions of how we actually put everything together. And again, the only reason our private key is hard-coded because we were going over an example, but moving forward, we won't be seeing our private key inside of our code any longer. Like I said, that is a security issue, so that is shied upon. And we're actually going to make sure that our private key is secure and not hard-coded within our code. But with that being said, we're going to pick up tomorrow where we left off today, and we're going to keep moving forward. Of course, I will keep you posted every step of the way. But for now, it's the Python Papi. You guys stay Gucci.